Electrolysis is a process that uses electrical energy, usually a battery, to cause a non-spontaneous process to occur. So an example of electrolysis, and many electrolysis involve reactions like this, the separation of elements from a compound. An example is sodium chloride being separated into pure sodium and pure chlorine. This is an electrolysis like all these other reactions are as well. For example, the purification of aluminum oxide, bauxite. You can get your aluminum foil from taking ores such as this from within the earth and running them through electrolysis to get pure elements. And then finally we have the electrolysis of water, which separates it into its elements as well, into separate hydrogen and oxygen. This reaction might allow us to isolate fuel from water and later use that fuel to be combusted in a fuel cell back into water. A means of powering our cars or our homes, hydrogen fuel cells. Now, we mentioned that these are non-spontaneous reactions, which I think should be fairly obvious. You know that any combustion reaction, the reverse of this reaction, is spontaneous. Hydrogen being combusted with oxygen is spontaneous. It'll give a nice pop. Or if you were to fill a balloon with hydrogen, or say the Hindenburg, you have a very large explosion. So that reaction in the reverse direction is quite spontaneous, but the reaction in the forward direction is non-spontaneous here. But you can drive it by adding electrical energy, usually using a battery. So we can see with the sodium chloride reaction, this reaction in the forward direction has a standard EMF of negative 4.07 volts. Having such a negative value, you know that this is a non-spontaneous reaction. However, you can drive it by using a battery which is 4.07 voltage or more. So if your voltage of your battery is greater than the negative voltage of the reaction, then you can drive that reaction significantly. All right, so we'll have to do a bit of math with regard to electrolysis. We'll be converting most often from current and time into the amount of product formed, or we can find from the amount of product formed and time the current of a battery, or we might ask how long will it take for a certain amount of product to be formed and for a battery to have a certain ampage current, how much time would the reaction occur. So we can interconvert between these three things using this pathway. So before we discuss and use this pathway, I'd just like to mention that current is amps or coulombs per second. This is the amount of charge transferred in a given amount of time. Current. Time, if you're going to be converting between time and charge in coulombs, you'll need to use seconds as your time unit because current is in coulombs per second. And then we also know that we can convert between charge in coulombs and moles of electrons because we know that 1 mole of electrons has a charge of 96,500 coulombs, Faraday's constant. So we can use this to solve a problem such as this. How much calcium will be produced if an electrolytic cell of molten calcium chloride of a current 0.452 amps is passed through a cell for 1.5 hours? All right, so in this electrolysis reaction, we're separating calcium and chlorine from each other from the compound calcium chloride. And so we see that the calcium ion, we know it's an ion because it's part of an ionic compound here. Calcium ion is turning into calcium metal, and that requires 2 electrons, and those 2 chlorides are turning into chlorine gas, and that is releasing 2 electrons. Now, we're asked to say how much calcium can be produced from using 1.5 hours cell and having an amperage, a current of 1.50 amps or 1.50 coulombs per second. So we know that this is the number of coulombs per second. We know we're running it for 1.5 hours. So how many coulombs will be transferred if we run it for 1.5 hours at this current? All right, so convert your hours into seconds, and then for every 1 second, 1.50 coulombs are transferred. And so this tells you the number of coulombs transferred through this cell, and we know that for every 96,500 coulombs, 1 mole of electrons is transferred, and for every 2 moles of electrons, 1 mole of calcium is produced. Or for every 2 moles of electrons, 1 mole of chlorine gas is produced. We can convert from our moles of electrons into moles of calcium by plugging in this 2 as our number of moles of electrons per mole of calcium by considering that equation up top. And then convert from moles of calcium into grams of calcium, you get 0.50 grams of calcium. All right, so this problem allowed us to go, actually, I'm sorry, there's a slight error here. Yeah, it was 0.452 amps, so this should be 0.452 coulombs per second. It's 1.50 hours. All right, please correct that in your notes. Now, going back up top, we just went from current and time into grams. But if we wanted to go from grams into time, what we could do is convert from grams into moles of electrons, into charge of coulombs. So we would know the number of coulombs, and we would want to know how many seconds are required for a certain current to be transferred. So use that current that is provided to you, coulombs per second, to get you from coulombs into second time. Thanks for watching, guys.